A population of endangered birds decreases by 0.75% each year, and there are currently 203,500 of the birds in the world. How many will remain after 20 years? The fact that we have a percentage-based decrease is our indicator that we're going to want to write a exponential function. Now, filling in the remaining parts of the exponential function is a matter of understanding what these two words mean, or these two numbers, mean in the context of the problem. So first, the 203,500, that's our initial value for the population of the birds. If 0 years had gone by and we used 0 as the exponent, then we would get a population of 203,500. But we're not interested in 0 years. We are interested in a number of years beyond the first. So we're going to use x as our representation for the variable. Now, the key part of this question is placing the correct number where the b is. And that's where the 0.75% comes in. Telling us that the population decreases by 0.75% alerts us that we are looking at a decay situation. We should anticipate that every year the value of the population, the amount of population, is decreasing, is going down. Now, the factor that we use as the base of that exponential does not just say, just put 0.75 in there and be done. What that factor uses is what would be left over after that year is already finished. What's the percentage of the population still remaining if that 0.75% was removed from the population? And that's where our use of the number 1 comes in. So thinking of the number 1 as a representation for 100% and using 0.0075 as the decimal version of 0.75% gives us a base of 0.9925. And that's the base we're going to use for our exponential. Exponential functions are written not in terms of what's gone when that year is over, but rather what percentage of the population still remains when that year is done. So if 0.75% of the population is gone, then 99.25% of the population remains. And since we're writing these in an equation, we use the decimal version of the percentage instead of the actual percentage. It's at this point that after the exponential function is written that we can substitute in our 20 and actually evaluate this function for the population after 20 years. Now, here's the interesting thing. Calculators can be a little finicky when you type in these numbers and this sequence of evaluations. So I always start by calculating first the exponential part, the exponent part, and then from there multiplying by the 203,500. If we do that correctly, this percentage, or this calculation, gives about 86%. That's interesting because if we lost 0.75% over the course of 20 years, we would expect to lose, like, you would think like somewhere in the neighborhood of 15%. That's what we ended up losing, is about 14%. So 0.86 times the 203,500 gives us a final population of 175,55 birds. So walking through this one more time, just making sure that we're familiarizing ourselves with the key parts. We start with the basic exponential. We use the initial value as the value for A. We use the percentage to determine our decay factor. Remember, 0.75% being taken off means that 99.25% is being left on. We evaluate that exponent at the correct number of years. We multiply it by the initial value, and we get a number of birds at the end. This sequence will hold provided that you are given those two key pieces of information. The percentage that is going off or increasing by if it was an exponential increase, and the initial value.